constant rates. For example, we discussed that distance is equal to rate times time. Let's say we have a rate of 70 miles per hour and a time of 2 hours. This is easy enough to find what our distance is. We simply plug it in. Distance is equal to 70 times 2. And 70 times 2 is equal to 140. And so we have our miles. So if you're asked to do a table and you're given an equation where distance is equal to 2 times t. Let's say that somebody is going 2 miles per hour, maybe a jogger or somebody that fast. So what we're going to do is let the 2 be the miles per hour, and t is equal to time. This is defining your variable, and d is equal to distance. Now we can make a table easily with this. You've got your time and your distance. So if we plug in some numbers, let's say we let t equal 0, then d is equal to 2 times 0. d is equal to 0. So if you are not doing the time, you're not doing the distance. Now we can also plug in t equals 1 hour. So d is equal to 2 times 1, which is equal to 2. So we can make a nice little table knowing this. And so now if we say that t is equal to 3, or to 2, excuse me, then your distance will be 4. And if t is equal to 3, your distance will be 6, and you can just go on forever with that. The other thing that is important is how to make a graph, and definitely you will use graph paper, but I have no choice but to do it this way. Now everything depends on time in order for distance to be traveled. So time is going to be my independent variable. And let's say I have 1, 2, 3, 4 hours. And my distance will be 1, 2, 3, 4, 5. And so what I want to do is look back at my table. I have 0, 0. Then I have 1, 2. So what I do is I go over 1 and up 2. I also have 2, 4. So I'm going to go over 2 and up 4. And I can draw a line here, but as you can see, my rate is going to be over 1 up 2. So I am attaching a paper to this podcast so that you can do it, and please refer back to this if you have any problems. The end.